Hello everyone! The goal of this video is to help us become familiar with some of the key terms used in the rhetoric of generative AI. But more than just memorizing vocabulary, what we want to do here is begin to understand how AI, for lack of a better word, thinks. We want to understand the processes by which it learns new information and uses that info to generate anything from surreal images to film scripts. And so we might begin by thinking a little about how we humans learn anything in the first place. Let's say you're a pretty decent piano player, and you're tasked with learning a new and very difficult song. How would you learn to play it? Well, of course, you'll practice like crazy, and the more you practice, the more those patterns will become familiar to your brain. And with that repetition, certain neurons in your brain will work together when it's time to perform, reminding you to move each finger differently at various speeds at different parts of the song. You'll also make the process faster by naturally connecting the task at hand to things that you already know, using familiar chord shapes, patterns you've used many times before. You're drawing on neurological connections that already exist in your brain to make something new and strange seem familiar. The last thing to do, of course, is grow an extra pair of hands, but we're not quite at that stage of AI human enhancement, so let's save that for next year's video. Now, if we ask AI for more advice on learning how to play this song, it'll give me some specific notes here. And this advice is based on information that the program puts together from its neural network. A neural network is a machine learning program or model that makes decisions in a manner similar to the human brain by using processes that mimic the way biological neurons work together to identify phenomena, weigh options, and arrive at conclusions, according to IBM. And these networks have a way of learning information that mimics the learning processes of our human brains. Apps like Perplexity and GPT are what we call large language models. These are programs that have learned to mimic human conversation by taking publicly available text from the internet and using complex mathematics to determine how each bit of information is related to all the other bits. Just like a human brain, they have billions of neurons in their network, in this case, artificial neurons. And when GPT or Perplexity is tasked with teaching us to improve our piano playing, for instance, this is where its advice comes from. Now, humans would give you advice based on life experience, whereas LLMs generate advice by processing huge amounts of data from their network. And because these LLMs give us answers without really understanding the context of those answers, at least in the way that humans understand, some in the tech world refer to these models as stochastic parrots. I mean, stochastic meaning random, and a parrot, unlike our wise owl friend, is a bird that repeats what it's conditioned to repeat. The idea is that these large language models generate language or art, but they don't understand or appreciate what it is they generate. It's just mindless repetition. Now, others, notably the cognitive psychologist and computer scientist Geoffrey Hinton, considered to be the godfather of generative AI, believes that LLMs are capable of thinking, that is, of analyzing how the world works. Now, to understand his perspective, we need to take a step back to the 1970s when researchers were starting to develop a new academic field known as deep learning. Now, in the 1970s, these AI scientists worked in the language of symbols, using symbols to try to teach machines to generate ideas based on related concepts. For example, if you put all of these words together, they will probably make you think of owls. And by the same logic, you could train machines to make similar associations with the right terms and symbols. But for these AI scientists, it wasn't enough just to get the machines to memorize or reproduce data. They wanted the machines to be able to learn on their own. So to illustrate, let's look again at how humans learn. Let's say you find out that owls love to eat tacos, and why not? Tacos are delicious. Now, if you believe this, your understanding of similar objects will change as well. If owls like tacos, maybe they also like burritos. If owls like tacos, maybe sparrows also like tacos. In the latter case, you make the assumption because your own neural network understands that birds share certain features. And thus, certain neurons that represent those features will fire together with slight differences when you think of those two birds. In a case like this, your neural network might learn to see taco appreciation as another shared trait between owls and sparrows. So when you think of these birds together, and the neurons associated with owls and sparrows fire at the same time, why doesn't your brain produce some fantasy creature that's a cross between an owl and a sparrow? Well, because a smart brain will change the weights among the neurons to establish a logical connection between them. In this case, understanding that these two birds are distinct creatures. Now, an LLM like ChatGPT will go through a similar process, producing output based on probabilities, which are themselves based on billions of mathematical weights in their neural networks. The same process occurs in the human brain, though in our brains, the weights between neurons are built into their physical connection, while in AI neural networks, these weights exist as numbers. Now, what's interesting here is that in these LLMs, the weights can be manipulated. In 2024, the AI company Anthropic was able to locate the specific neurons that fire at the mention of the Golden Gate Bridge. And by intentionally making those neurons stronger, researchers found that their AI program Claude would always incorporate the Golden Gate Bridge into text that it generated. For example, ask Claude to recommend some taco toppings and you stimulate those bridge neurons. It might just recommend salsa, cilantro, and a few generous rusty scrapings of the Golden Gate Bridge as a garnish. Perhaps not the most appetizing dish, but it brings us to our final question. How do these LLMs generally know the right answers to our questions? When we're making tacos, why do they not normally suggest rusty paint flakes as a condiment? Well, this is where the training comes in. In particular, a form of training known as backpropagation. This can be a complex idea, but to simplify, it's a way of testing AI programs for errors by working backward from the initial mistake. So let's say our LLM is tasked with coming up with a tasting menu for a new restaurant. When part of that LLM chooses a menu item that's very inappropriate, say shoe polish pate, a part of the program acts as a judge and tells the rest of the committee to identify which member was responsible for that inappropriate choice. Of our owl friends here, it looks like this one thinks that shoe polish would make a good garnish. Now, the backpropagation algorithms will then go back and see why this owl disagrees with the otherwise universal standards. Where did this owl develop this abnormal taste for shoe polish? Was it from his parents, an evil chef at the school cafeteria, etc.? Once the algorithm knows, it can go back even further and see where that bad information came from. Through this process, the network adjusts itself to listen to wrong sources less proportionately and favors sources it deems correct. An easier way to think about this, and another method used in training, is called reinforcement learning with human feedback. And this is when a human helps the AI decide what kind of information is correct. At Microsoft, researchers would ask their LLMs inappropriate questions and request two responses. Then they would tell the LLM which response was better. Over time, the LLM learned on its own what the best response would be. And since 2024, AI is now being used in place of humans to provide reinforcement learning with artificial intelligence feedback, which could itself be the subject of another video. Now, all of these processes we've been examining probably sound very logical, but what makes AI such a fascinating science is that we don't have all of the answers. In training LLMs, new structures will form even when not prompted by human engineers. And there's an entire branch of AI science devoted just to understanding why generative AI produces the output that it does. This is known as interpretability, the study of AI decision making. While this is a discipline-specific computer science term, it points to what could be the most fascinating aspect of this collective AI experiment that we've all become a part of, whether we like it or not. Regardless if you're a writer using GPT for the first time to come up with a creative writing prompt, or an advanced data scientist studying the nuances of deep learning, we're all participating in this ongoing activity to try to learn why Gen AI does what it does. And as such, we're all playing our own roles in helping to shape how this fastly emerging technology finds its way into our culture and creative lives. That's all for now. Thanks for watching.